Hi, and welcome to How Do I BI, a mini-part screencast series on using SQL Server Analysis Services 2008 based on my book, Smart Business Intelligence Solutions with Microsoft SQL Server 2008. I'm Lynn Langett, Developer Evangelist with Microsoft in Southern California. And in this edition of How Do I BI, we're going to take a look at the algorithms included for data mining that are time series, neural nets, and more. Before we do that, we'll discuss the FAQs and gotchas. As mentioned in the previous two screencasts on reviewing the included algorithms, I always recommend to look at the samples and in particular the included data mining model viewers, because that's going to help you, especially if you're new to data mining, to understand what it is exactly these algorithms are doing. The samples we're going to be looking at in this screencast are the forecasting sample for time series and a targeted mailing structure, which includes our neural net model for neural nets. There are two algorithms for which there are no samples, but we'll briefly be discussing those as well. Those are linear and logistic regression. It's important in terms of the gotchas that you understand the content types that are required. For example, for forecasting, you must have a content type from the source that's marked as key time, so time series can be determined by the algorithm. Also, it's important that you use neural nets for the appropriate business situations. It does have a very, very high overhead in terms of processing compared to some of the other algorithms. For more details, see the information in my book on this topic. And now we'll go to the screencast. We'll be examining a couple of the included data mining algorithms with SQL Server Analysis Services. In order to do that, I've opened the AdventureWorks sample, and I've opened two sample data mining structures, the first of which is called forecasting. And this structure, we will be looking at the time series algorithm. Before we do that, I want to point out a couple of requirements in terms of the modeling data. So we're modeled off relational data here, so you can see a time series, and we're going to go ahead and open that and explore the data. And we'll see that the time index value is the indicator for time, and that requires a particular content type marking. So when we go over the time index column and we look at the properties, if you scroll up, you'll notice that the content is marked key time, and that is required for a time series algorithm. Another important point for a time series is that there has been improvement made in the algorithms available that underlie the top level algorithm for 2008. And what I mean by that is revealed if we look at the mining model itself. So if we go into the mining model and we see that this has been set up for time series, and then we click on that, and then we go over to the properties, and then we click on the algorithm parameters property to open up the build box, which will show us the various parameters. If we scroll or we take a look at the forecast method, which is the third parameter, we'll see that by default we're using two underlying algorithms. And I won't take the time in the screencast to read the entire thing, but from a high level, they're ARXTXP and ARIMA, and they are more useful for different types of time series calculation. One is for shorter term and one is for longer term. If you have the standard edition of Analysis Services, then you'll get this blended use of these two algorithms. If you are working with the Enterprise Edition, you have the ability to configure this, and this is a specific request that our customers gave because they were wanting to be able to work with time series data in this fashion. To understand what this might look like for the end users, you click on the mining model viewer, and once this renders, we will then see a chart which shows the values, the predicted values of the, these are bikes in this case, of the bikes over time, and we can select or deselect the predicted values. We can adjust the prediction steps. There are many different ways that you could be displaying this time series data, but this has been a highly popular algorithm with many of the customers I know that I've worked with. So that's the time series algorithm. The next algorithm that we're going to take a look at is shown as a sample in the targeted mailing structure, which contains 4 total mining models, and that is the neural net. Neural net is used in situations most commonly where other algorithms fail to produce meaningful results. And in a future webcast, we'll be talking about just exactly how you ascertain which results are most meaningful. But suffice it to say that this is generally the algorithm that's used last in the series of mining. And there are several configurable parameters inside of here. So we'll go ahead and go over to the properties and click on algorithm parameters and open that dialog box up. And you can see that these include things like hidden node ratio, holdout seed, sample size, so on and so forth. It's interesting to see the output that's shown inside of bids for neural nets. So if I click on the mining model viewer and wait for it to render, we'll then see a little bit different view than we've seen in some of the previous outputs from the mining models. You can see I've set the mining model to neural net. The viewer is Microsoft Neural Network Viewer. By default, we're looking at all attributes from the input standpoint, and from an output standpoint, we have the output attribute bike buyer and the value 0 or 1, so whether a person tends to buy a bike or not. And you'll note that, for example, the most closely correlated values are sorted within the attribute ranking. So you get a graphical representation of who buys bikes versus who does not buy bikes for all attributes. If you wish to filter this, you just click on the input section under the attribute drop-down list. And for example, if we wanted to look only at people of age under 35, then the results would be automatically filtered, and we could subsequently apply more filters. For example, we could say we only want to look at women under 35 and what their purchasing patterns are, and so on and so forth. So this is just one example of a viewer. The algorithms that we have not covered, I'm going to go ahead and show you by creating a new mining model structure, or starting to using the wizard that's included. And to do that, I'm going to right click on the mining structures folder and click new mining structure, and click next in the data mining wizard, and then select from an existing relational database. And in the third dialog box here, we need to select a data mining structure. And now that we've had a brief introduction to the mining algorithms, these brief descriptions will probably be useful for you to help to remind you which algorithm does what, if you're not as familiar with data mining concepts in general. We've covered all of the included algorithms except for the two that are not included in the samples, and these are linear and logistic regression. So if I click on linear regression, there's a pretty good description underneath the wizard's dialog box here. That's interesting to note that, as it says here, the algorithm is a particular configuration of Microsoft Decision Tree's algorithm, and you disable splits basically. For details on how to do that, again, you can either see books online, or I have detailed that in my book. Also, we have Microsoft Logistic Regression, and you can see that Logistic Regression is a particular configuration of Microsoft Neural Network algorithm that we just looked at, specifically, as it says, by eliminating the hidden layer. Also, there's information about the types of attributes that are supported by these various algorithms. In the next screencast, we're going to go into more detail on the content types. We have covered now all of the various algorithms. I encourage you to spend time in the samples with the mining model viewers, and also I remind you that there are data mining add-ins that you can use with Excel, which many developers have found helpful in their path learning data mining. Thank you.